Okay, so this is going to be a video on the study questions test calculus this week. So let's start. First question on the study guide says find the derivative of 5x squared 7 at x 7. Find the derivative the polynomials, the power rule on each of squared plus 5, and then we're going to evaluate 7 squared is 49. 49 plus this is 40 times 49 is going to be 49 half of 5. This 5 and 90, 180, 280. So we want to calculate control 7. Okay, so 1 to 7 of squared plus 5. Now remember, you can take these practice quizzes often, like some extra practice you can. It'll keep the highest score you have, but it'll keep the highest score for the whole entry. I guess that is one. But go through and get all of the points and decide I just really want to practice question 3 a few times. Run it a few times, it'll keep the highest score. Anyway, this is also a power rule, so we'll power rule on each. It goes up to a third power, and we divide by 3. Square, divide by 2. This one goes up to x, divide by 1. Do anything. Evaluate from 7. Negative 2/3 of 7 cubed. 7 times 9. 49 times 5 and subtract. Halves 5. Well, if we have 343 copies of negative 2, we're going to 303 over 2, 7 over. Here. negative 2 goes into 300. 3 goes into 4, 1. Here goes into yeah. Pi antiderivative of derivative of sine plus squared pi pi sine of pi pi squared over pi over pi sine all of that sine of pi x of Well, this part is an x. So the antiderivative is for an exponent. Take the antiderivative. You're going to get dx divided by the natural log of this one here over the natural log of e is and anything divided by plus thirds 3 evaluated. So get 4 3 plus 20 times 3 to the 3 minus 4 times plus thirds or e. That doesn't simplify. We can cancel. Now we have over here we have 4 times 0 is 1. And 0 times anything. And then we terms third exact value. You can throw that into a calculator, decimal approximation. Feel free to use your. Okay. Match sine possibilities. We want to match up these functions on the left with edge. First off, this one doesn't have. They'll all have some sort of arbitrary. The other ones all have c. Now, the derivative of sine is cosine, but we're not looking for derivatives. We're looking for. This is a nice chart when dealing with derivative of sine, cosine. Derivative of cosine is negative sine. Derivative of negative sine is sine. Then it wraps back up to. So we're looking for the antiderivative. We start at sine and we go backward. Negative cosine. Cosine, we go back a step. This way, derivatives. This way is sine at to the power rule for antiderivative integrals, add one to and we divide by the new. So got that. Antiderivative of 2x plus 1 squared plus x. I'll have to add the correct for what. Anyway, this one here by the same reasoning, powers divide by the power. I would have had one matches with constant. That's the one. So this shouldn't be an option. What I've done, obviously, for some question derivative instead of which I just now this will be one of the functions. Response question. What is the derivative? That derivative. Remember, this one is a quiz, so we can look things if we're unsure of maybe seek. That'll be quiz. For the test, you won't be able to look up stuff, but we'll just brush up on some of these trig and logarithmic for the test and make sure that you have 6 trig function, natural log. You want to be able to those. So find derivative natural log of and we'll do our arbitrary capital X. Might need our log X. Third, we put it. What we might want to do is find antiderivative of sine x. cosine of x x I think it's the negative of a of log. If we have the that would be x over the Next, zero. Now, it says to use L'Hopital. L'Hopital's rule only applies if, when we plug value in the top function, we get either a 0 over 0 indeterminate or an infinity over infinity. First, let's just plug those in. What happens? Get 0 cubed tangent 0 and into. So, what we do is take the derivative 3x squared, derivative of the denominator, and then we plug in the values. What we get 3 times 0 squared, secant of 0 over 1, which is 0. Since this limit exists, it equals that limit. Limit 0 of x gives us a 0 over 0 indeterminate form by L'Hopital. 0 third x, which equals squared 3 over squared 0 over 1, 0. So there is limit. It's the same calculation. Those are all of the questions I have on. Brief look here. Look, first question, definite integral. With polynomial has a number here and a number here, has some sort of polynomial here. That's how you question. Have 2 is also a definite integral. It's spelled however it's spelled. This one has a trig plus a polynomial. Go from A to B, trig function, polynomial. Question. Have an integral, definite integral, where we have and your value. question 4. This is a derivative product rule. And as polynomial times some other element, maybe a trig function, maybe an exponential, logarithm, root, something. I'm going to take the derivative of it, not the answer. Question 5. I'm going to find definite integral. The difference between a definite integral and an indefinite integral. If I have like the integral from 1 to 2 of x squared, it's going to be x cubed over 3 from 1 to 2. Get 8/3 minus 1/3 equals. This is definite. Now, indefinite have no endpoints. And I'm looking for cubed over plus c. This is a function. But a definite integral is going to be a number. It might be a fraction, it might be transcendental. But it will be a number for a definite. Last question asked. Last question asked L'Hopital. Might be the limit. Five. Natural law. We have this here. This, of course, goes to 0. This is infinity. That makes form 0 times. Rewrite this as x goes to right of. We have to either pick this one to be over this one. But I think that it'll be natural log of 5, 1 over 5. It doesn't work. Now, top goes to infinity, the bottom also infinity, so we get an indeterminate form. That allows us to top becomes 1 over 5. That's what happens with logarithms and derivatives. Bottom becomes negative over 5 squared. Cool. Write this 1 over x plus 5 divided by 5 squared. Dividing by a fraction. Dividing by this fraction is dividing by whole fraction. We're dividing by whole. Gives us the goes to 5 from the right. If we keep x top and bottom, this top goes to 0, go over negative 0. This this is me. I would natural log would have. Also, I guess we can look at Desmos. Not always. Having a graph that five and here graph. Notice as x goes to 5, the go to 0. The y as x value goes to 5, the x value goes to 5, the y value of the yeah. That's what's going to be on the test. I'm studying for it. Go for class. Some questions. Week test